Hello and welcome to Components of Number Sense, Session 10 with Mrs. Kelly. Today we will talk about the components of number sense. It's very important for us as teachers, parents, and educators and caregivers to know about the components of number sense so that we can help our children at home, in school, to learn about the different components of number sense and develop a great sense of numbers and the relationships that they have with each other. What is number sense? Number sense is an understanding and awareness about what numbers are, their relationship, their magnitude, the relative effect on operating of numbers, including the use of mental maths and estimation. How does number sense develop? Number sense is good intuition about numbers and their relationships. It develops gradually as a result of exploring numbers, visualizing them in a variety of contexts, and relating them in ways that are not limited by traditional algorithms. So there are four early numeracy concepts that we will be talking about. Number one is subitizing. Subitizing is the ability to recognize a number of objects or a number of items presented to a child. So if I give a child 5 objects, they should be able to tell me it's 5 without having to calculate finger count, verbal count, or object count. Verbal counting is when a child can recite all their numbers in orders and they know the names of the numbers as well in order. Object counting is slightly different to verbal counting. It's when they attach those names from verbal counting to objects. So for example, if I give a child 10 objects and they tell me the first one is 1, the second one is 2, third one is 3, and the fourth one is 4, so on till number 10, that is called object counting because they're associating a number name with an object. Cardinality is when you count all the objects and the last object in the group tells you what the answer is to the question. So for example, I present a child with 10 objects and I ask them how many objects do you see? So the child should be able to count all the objects and tell me 10 because when he reaches the last object, that's what should give him the hint that the answer is 10. So if a child is very good in cardinality, he will be able to tell you the answer is 10 because he will realize that after counting all 10 objects, the last object is going to give me the answer. But if a child is weak in subitizing, she might tell you 10 by counting 1 to 10, and you would know it's 10 and that she knows her numbers in order and she's able to object count, but she'll not be able to tell you that the answer is 10 because the last object tells you that that's the answer. Number one, spatial relationships. Spatial relationships are really important because they help you understand the relationship of numbers with each other using different objects and visuals. So here we have the visual of 3 dots and 4 dots. So this visual can help you learn that the number 3 is 1 less than the number 4. And if you add 3 and 4 together, it makes the number 7. It also teaches you that you can arrange the dots in different ways to make the number 7. So for example, if you pull this dot to this side, it would make 5 plus 4, makes 7. So that's how you understand the relationship of numbers in different ways using spatial relationships. What is spatial relationship? Spatial relationship is having a visual of numerals along with a visual of another numeral and using those visuals to help them see the relationships. When children see visuals, the spatial images come up and then we can have deeper conversations on how these quantities relate to each other. Building relationships starts with using a variety of visual spatial images of these quantities so that it can help us build the relationship we are going to talk about. 1 or 2 more less. This is figuring out the relationship between numbers and how they're related to each other in terms of being 1 less or 1 more than each other. So for example, on this reckon rack, we have the number 6. So we are trying to learn what is 1 more than 6 using these 2 reckon racks. So the first reckon rack shows us the number 6. And on the next reckon rack, we see 6 red dots plus 1 more red dot makes 7. So that's how we learn about 1 more or 2 less. Or if we had to move one of these red dots backwards, so 1 less than 6 would be 5. What is 1 more or 2 less? This is about instantly knowing what 1 and 2, more and less of any amount is. But again, visuals help with that. If we have the number 6 and 7 and you ask a child, what is 1 more than 6? Some might answer, some might find it tough, but if you show it to them visually using a reckon rec, they understand the concept better. Visuals help to make children understand math concepts even better because they learn visually and they're able to see the relationships between numbers in a visual manner. using objects. These spatial relationships lay the foundation for us to build those 1, 2, more or less relationships. The idea of 1, 2, more or less is not just 1 and 2. It is 1 or 2 of the benchmark amounts or less. Example, one set of 10 plus another set of 10 makes 20, or one set of 10 plus 2 tens make 30. Benchmarks of 5 and 10. So here's a picture depicting how we can know a number relates to 5 and 10. So how does the number 9 relate to 10? So 1 less than 10 is the number 9. It is about how children understand how numbers relate to benchmark of 10. When teaching kids about benchmark with lower numbers like 1, 2, and 3, we want them to learn how they relate to the benchmark of 5. So for example, if you're teaching a child about 1, 2, and 3, and you want them to understand how does 1, 2, and 3 connect with 5, you can show them using visuals that 2 plus 3 makes 5, or 3 plus 2 plus 1 makes 5. Basically trying to show them how the numbers relate and how they add up together to create the number 5 or the number 10. Using manipulatives in a 10 frame gives visual lessons to children and helps them understand how numbers relate to 5 and 10. Part whole. This is a very interesting concept in number sense, and it basically helps a child understand how many parts a number can be broken into, or how many numbers can add up together to create a whole number. So for example, 0 plus 7 makes 7, 6 plus 1 makes 7, 2 plus 5 makes 7, 3 plus 4 makes 7. So these different number stories or math stories tell you that these numbers, when they join together, they all create the number 7. So basically, these are the two parts that join together to create a whole. So one part plus 6 parts, if they join together, create 7 parts, which is the whole. Or 2 parts plus 5 parts join together and they create the whole, which is the number 7. So learning this concept is very important for children to understand. And using visuals helps them understand that better. Because for example, right here, 6 dots plus 1 dot makes the number 7. 5 dots plus 2 dots makes the number 7. 4 dots plus 3 dots makes the number 7. What is part whole? It is about taking a whole number or amount and breaking it up into parts. It is important for kids to learn how to break apart numbers. It is the stepping stone into addition and subtraction, making problems more friendlier. This develops by exploring numbers and visualizing them in a variety of contexts. Also, when you teach a child about part whole and how to break the numbers down, it's very important because it's a very great addition strategy that you can use with children irrespective of grade and class and irrespective of math concept. So it can go from being used in basic addition to geometry, algebra. Decomposing of numbers is really important. It's a very great math strategy which can be used over many grades. Number sense is caught, not taught. Children need to explore numbers, visualize numbers, build numbers and patterns, experience numbers. They also need to build their relationship with numbers in their own way, and this impacts their ability to be fluent in number skills. Building strategic mathematicians. Some phrases to use while teaching your child maths or teaching children maths in a classroom are, how did you figure that out? How are you planning to solve this? What evidence do you have to prove? Did anyone try it in a different way? Is this a good starting point? How did you do that? Explain to me how you came up with this idea. What strategy did you use to build this building? Why did you put 5 blocks on top of each other? Or why did you use 5 red blocks instead of green blocks? Can you explain to me? How do you know? What are you noticing? What are you thinking? I am thinking. So you're saying, can you imagine? What else can you say? Are you sure? Thank you all for watching my video. If you like my video, please like, share, and subscribe. Have a nice day.